Okay. Hello, everybody, and we continue with the final session of our conference. And the first speaker is Valeria Generalova, and the talk is titled "Modeling the Variety of Constructions with Morphological Causatives Metagrammatically, a First Sketch." Please.
Yes, thank you for introducing me. I'll share my screen now. And I've also uploaded my slides on chat because they'll have some code samples that might be difficult to read on the flow. So if you wish, you can follow in your own pace. Now I guess I'll start. So my talk will be somehow different from the other talk at this conference because instead of sharing some new typological knowledge, I will apply the existing concepts to some kind of an applied or even of an engineering task. So the area my talk is best situated in is the area of grammar engineering. It's growing popular due to overall digitalization of academic knowledge. So the ultimate goal of an ultimate project in the area of grammar engineering will be to create some kind of formalized description that can be programmed as a tool for both parsing and generating sentences, any kind of grammatical sentences or even acceptable sentences in any language of the world. Of course, it's too ambitious, so the real projects that exist need to narrow down the scope somehow. And today, presenting my first sketch of my project, I will present only a handful of languages, but I'll talk about a solution how to cover more languages within the same solution. And also, I will limit myself to only one specific type of sentences, to only one type of constructions, namely constructions with a morphological causative with a base transitive verb. I guess the audience is quite familiar with this construction. I just would like to underline that what is important to me is that the construction is monoclausal and the causation, the causative meaning is brought by some kind of an affix, a morphological device, and that it comprises three arguments because the main interest of my project is to model the verbal derivation. So what I am interested in, I would like to know what linguistic concepts, so what data, what parameters discovered in comparative studies, fieldwork, studies of individual languages are most relevant for creating this formalized description, also called a metagrammar, of these three argument causative constructions. And under most relevant, I understand, first of all, that they are sufficient to distinguish between different causative constructions at the same time that this range of concepts is necessary to describe the key properties of these constructions, and also, which is important, that they can be adequately formalized and adequately used in a formalized context, which might seem going too deep into technicalities, but in fact, the power of the logical language, of this meta language of description, can imply some decisions in the analysis. And for that, I would need a short background section. So the grammar engineering area of projects basically has two main components: a grammar theory, which can be any grammar theory, and some kind of a tool or a set of tools. Probably some of the audience, some of you are familiar with the Lingo Grammatrics project, which is done in the University of Washington. They use HPSG as their underlying theory and the Delphin toolkit. Here in Düsseldorf, in the Tree Grasp project, in which I'm a PhD student, we use Roland reference grammar by Van Beelen as our underlying grammar theory, and the XMG language for writing metagrammars, and I'll present it in a while. So there are also other tools like tree description languages, parsers, and so on, but they are outside of our scope today. So the XMG language stands for Extensible Metagrammar Language. Is a declarative language in a sense that it describes static constructions and not dynamic procedures. It is notationally expressive, which means that it has some operators. For example, here on the slide, you can see a disjunction. You can see conjunctions with this operator sign, and also some specific dominants like here and precedence like here, specific operators within a dimension. It also has a mechanism of inheritance, which is very important for our talk today, and a type checking system, which is also a big advantage of this formal language. And this language is extensible in a sense that it can describe arbitrary number of dimensions, and one can write more modules. So for example, here we have a syntactic dimension that produces this kind of structures. Oh, well, it's basically tree structures, but RG trees are somehow different from trees in other formalisms. And a frame dimension, which describes semantics in the shape of decompositional frames. And also, XMG is extensible in a sense that it can describe any underlying grammar theory. So the code sample that you can see on this slide is, well, a little bit complicated, but I would like to walk you through the key features of the language. So the class is the main code unit, which comprises a description of something. So in this particular case of one construction that produces two representations, the syntactic one and the semantic one. One can declare variables in the beginning of the class and use them either as instances or as feature values, which you can see in light blue. And in this case, a feature value becomes, well, is represented as a label, like here. But normally features and their values, as you can see in pink and orange, are defined and listed in the preamble of the metagrammar, and they are type checked. So one cannot type an arbitrary string as a feature or as a value. And as I've already said, there are operators, and we'll see more of them in a while. So what I will be presenting today is a solution, an architecture that describes constructions with a morphological causative and with three arguments that accounts for a typological variety of these constructions that is firstly suited for parsing, but after some modifications can be used for generation as well, that takes as an input sentences in an individual language, and suggests the above mentioned analysis for that. And also I'll talk a little bit about how to cover more data with this architecture. So in order to be able to describe both cross-linguistic generalizations and language-specific features, I suggest the architecture that would comprise two main types of classes. So the first one is the construction class. So it would describe and describes the theoretical concept of a given construction. Well, a three-argument causative monoclausal construction for the goals of the present talk. So there, all the syntactic nodes are introduced, provided with relevant features linked to the semantic structure. Varieties encountered in different languages are also listed in this construction type. We'll see that in a while. And also relationship between different constructions can be tracked. For example, causative will be represented as a verbal derivation and not as a construction built from scratch. To ensure the correct parsing of each particular sentence in each particular language, we would like to introduce, thank you, to intersect a construction class with a language plugin and a language plugin. is also a class in terms of XMG, but in contrast, it does not contain any syntactic or semantic dimension, but it comprises a list of features that describe relevant properties of each given language. Now, what do we model in our solution? So first of all, the syntax of causative derivation, as I've already said, causative is a verbal derivation and is due to a valence increasing operation. And here is how it's done. So the upper image shows a transitive construction with two noun phrases. Each of them has an identifier and a morphological case assigned. It's not very visible in this representation, but as the value of this feature, there is a variable that indicates which case would be used. So, and this label D7 stands for the case normally used for the syntactic subject, or in RG terms, the PSA, the privileged syntactic argument, well, nominative for nominative accusative languages, or some other case for other languages. And respectively, the D8 case is the one used for undergoer. Again, accusative if accusative, other if other. Well, when a causative derivation happens, it is attested universally that the new argument, which is in red here with the new identifier, receives the PSA case, and it is reflected in our representation. However, the case marking of the two other constituents varies depending on the language and on the type of each particular causative construction. So therefore, we need to change these labels and we assign new labels, empty for the time being, and we fill these labels with particular values of these features once the language plugin intervenes or some other conditions are met. The second thing we model is the universal semantic structure. So it also has been proven in prior scholarship that causative constructions have the same frame of causation, which comprises two subframes, the subframe of cause and the subframe of effect. And within the effect subframe, there is the embedded frame structure of the base verb. So we have a general transitive placeholder here. Of course, depending on the lexical semantics of the verb, it might differ a little bit. For example, thematic roles might be different. Let's see how we model that in code. We declare a class for causative affixes as we deal only with morphological causatives right now. So, and as the causative semantics come from the affix, we model this causation, this cause subframe within the affix class. Similarly, within the root class, we model this lexical frame of a verb because, well, that's the lexical root that determines the semantics. When it comes to combining a class for a verb, we have two options, which we disjoin with a disjunction operator. If the verb is non-causative, if the verb is non-causative, its frame equals the frame of the root. However, if the verb is causative, we import both frames, the root frame and the affix frame, in the big causation frame. So we do not build it from scratch, but we inherit the information from other classes, which makes our architecture more flexible because we can reuse the same information several times. These were two main concepts that are universal for all causative constructions. However, we would also like to account for the variety of causative constructions attested cross-linguistically. And here there are two ideas to bear in mind. First of all, one language can have several causative constructions. You can see one example on the slide, but I'm pretty sure you're familiar with this phenomenon. So if one language can have several structures, this is the language plugin, where we must tell whether a construction in this language is allowed or not. We do that by listing Boolean variables for each type of constructions within the language plugin. So this is the variable language features that comprises all the features. This table that you can see on the slide is far from being exhaustive or even typologically representative, because we have no goal to do any quantitative generalizations right now. And instead, we've picked a couple of languages that demonstrate various causative constructions. So it can easily be expanded, so more columns can be added, so more languages can be described. And in the end of our study, we would complete it with some more rows. And it will result in a closed list of marking patterns used in constructions with morphological causatives. And we will account for all these constructions in our list of Boolean variables in the language plugin. The second part of the question of typological variety is, how do we attest the same construction in various languages? So we've already seen dative construction in Bashkir. I'm pretty sure you know many other languages that use dative for that, but also some languages that use the same marker for the causee as for the recipient in a prototypical ditransitive construction, but it is probably not the dative case, just because there are no cases in a language, or that depends on the morphology. So we would like to account for the concept of this type of a cross-linguistically attested construction in our construction class. And for this, we use the conjunction of different claims disjoint. And the disjunction of conjunctions works as an implication, a well-known De Morgan's law. So what happens here? We just, so it's a heavily cropped code sample. So somewhere in the syntactic dimension, we declare the node for the NP, which stands for the causee, and we assign a feature of morphological case, but we don't know which case exactly it should be. So we assign an empty variable for the time being, and then we go through the list of those constructions that we've determined on a previous step. We've just seen it. So if, for example, we are in a construction where the causee is marked like the recipient of a detransitive construction, to this empty variable, we assign the value of the feature of the recipient case in each particular language. So it might be a little overcomplication for the time being, but actually this is the way to account for morphology of each individual language, separately from the cross-linguistically generalizable concept of a construction. I guess this next slide will illustrate this better. So we've already seen some examples from Bashkir language. For example, there is a construction with ablative marking of the causee. Interestingly, the same case, ablative, is used in passive constructions for demoted agents. The same trend is observed in Kalmyk language, which is a closely related language. So also there is the same case used for causee marking and for demoted agent marking, but it's another case, namely instrumental. So for us, it's not a problem for our architecture because we account for the type of construction with a causee marked like demoted agent and passive in the construction class, and we assign the value of each particular case in the morphological part of the language plugin. The features are unified by name, and then their values are taken from this class. Again, our architecture is modular and flexible. So I'm afraid I need to finish soon, so I'll not read again all the claims I've made as a summary, because basically what I promised in the beginning of the talk, I hope I've convinced you that I showed. An important note to make is that while creating this formalized description from a formal perspective with a keen attention to describing very atomic structures, I've noticed some overlooked linguistic phenomena. For example, I've not encountered any comparative studies of relationship between marking of the causes and marking of demoted agent in passives. So it has been attested for individual languages, but well, probably further research in doing this comparatively is needed. And also, ditransitive constructions are well known for their similarity with causative constructions, but actually there are several types of these relationships, namely Halkamelian, a Salish languages of Northern America, appears to behave differently from a better known pattern illustrated in this presentation by Kalmyk or Bashkir. So it implies some further research in detecting exact correspondences, not only between constructions, but between particular constituents within constructions in languages and cross-linguistically. I've also promised to suggest a solution how to expand this architecture on more languages. So it is an example for Nivkh and isolated languages of Sakhalin, which is known for its very special marking of a causative construction. For our architecture, it's not a big challenge because we can easily attest for this special morphology in the morphological part of the language plugin and in the list of Boolean variables for constructions. And also we can easily cover more constructions, so active constructions with other valencies, passives, applicatives, and many other verbal derivations, given this inheritance mechanism and this general architecture of inheritance and intersections. And I'm afraid I have to stop now. Thank you very much. And I'm open to your questions and comments.
Okay, thank you, Valeria. We have about 7 minutes for questions. So please.
Shall I stop sharing or leave the slides to
Maybe
refer them?
it's better to keep your
Okay.
presentation on the screen. Okay. Well, the audience asked. Okay. Materevich, please, you can put your question.
Mati Reinovich has a question.
Yes,
Yeah.
I would like to ask: Did you show any examples of class inheritance?
Yes, some class inheritance has been shown here. So actually, here are two different mechanisms of importing data from one class to another is shown, and this is how it is done. So either we can import a class altogether through the import method in the beginning of another class, as we do with the root, because we inherit all its variables and we use them all across the new class. Or we can also import a class like this, like line 7. So it is more of an inheritance rather than an import in strictly speaking programming terms. So we just reference this class as a variable and then access some variables from that class, this particular variable, by name through defining the path to it. So this dot represents a path to a variable. These are two main mechanisms of how it's done in XMG.
Thank you. But are also languages represented by classes, or you don't have a class for each language?
I have classes for each language, which is called a language plugin. And currently, I do not have any inheritance between languages because I'm still in development of the exact shape of those language plugins. But I'm pretty sure that I will be doing some grouping there. I'm not sure yet how exactly, so either by genetic relations, and that's why they will be similar, or just taking into account only typological similarities, like a super plugin for accusative languages, and so on. But I am planning to do that, yeah.
Okay, thank you.
Okay, more questions. I myself do have a kind of maybe too philosophical question about all this. I'm also doing some kind of language modeling in computer science, and I'm wondering what's the overall goal of such a project. I mean that if you start describing a kind of meta language as you did with your detailed classification of language type, and then if you put some language data of the data of some language inside such a framework, so you should know in advance what do you expect from any particular language. So but on the other side, I might be wrong, but I understood that you expect to find some cross-linguistic generalizations by this tool, and what could they be if you know in advance about every particular language how it is constructed?
Well, I might have put it in a wrong way, but what I'm doing is that I don't know in advance so about each particular language. I know what I can find in a grammar, so its morphology and perhaps a range of constructions it has. Or probably I'm not sure about those, so I'll leave those variables open, and I'll have some over-generating tool. On the other side, what I know in advance are some typological cross-linguistic generalizations, for example, like all causers become syntactic subjects. This I can claim because there is a huge scholarship about that. So what I would like to have is to be able to create very complex syntactic and semantic structures like those trees and frames linked together, telling us about each constituent, how it is marked, how it functions, whether it is a macro role bearer in RG terms or not, which thematic role is assigned to it, by just intersecting the very basic morphology described very easily in those feature structures, with also well formalized the whole bunch of typological knowledge we acquired through prior scholarship. So, it will be a more philosophical answer, and a more practically oriented one will be that it can, so through a very easy specification of morphological features of each language, understudied perhaps, or even, I don't know, these descriptions can be provided by language activists and not trained linguists. We can generate parsers for those languages easily, because all the hard linguistic stuff is done, say, universally. So we could create a well-parsed corpora of minority languages, for example.
I see. Okay, thank you for the answer, and let's thank Valeria for her interesting talk. Thank you so much.